In this lab, then, you collected data on the volume and pressure. And so it tells you to convert the pressure at ATM, convert to true volume, and then create a scatter plot. So you take your volume, add 0.7 to get the true volume. You take your pressure, convert to ATM. Oh, and then the true volume to liters, and then you'll make a plot, and and then it tells you to fit it into the form factor of y equals mx plus b. And so when you plot it, it should look more linear, even though the r square is only a small improvement. So that's all you need to do for part one. For part two, you have your pressure versus temperature. It tells you to take your temperature, convert it to Kelvin, pressure into kilopascal, from kilopascals to ATM, and then make a plot. Label the axis. Should come out nice and linear. For the third one, this is more complicated, and that's where you had to measure the weight and empty and dry. And so you're going to have the mass of your flask empty, mass of flask with water gives you the mass of the water, the temperature of the water gets the density, and then that volume and density, mass and density gives you the volume, and then we'll add 3 milliliters to get that true volume. And then you're going to simply add. I did steps of 10, so that's all how I'm getting the speed total. You'll do your pressure to ATM just like before. And now for mole equivalents, you're just going to take this number and divide by this number. That's how you do all those. And you'll plot pressure versus mole equivalent, and should come out nice and linear. On the experiment 10, then that's where you added the magnesium and you had it in the flask, and then you collect data. You should have 2 plateaus, and then you're going to determine the initial and final pressure. So you'll use this kind of table. You have the mass of the magnesium and convert that to moles. Then using the balance equation, moles of magnesium to moles of hydrogen. You have your initial and final, so you can get the change in pressure. That's the 2 plateaus, similar to the calorimetry. You'll just choose the average temperature from your temperature reading that goes with it. And the vapor pressure is 0 because we didn't have any, the water was already present. So any change is due to the partial pressure of the hydrogen. And lastly, we have the volume you got from that mass reading, similar to what you did the experiment before. And so then to get this experimental moles, you're just simply going to plug into that ideal gas law. You have your pressure, volume, temperature, and the gas constant. And then everything else should make sense. So that's those labs.